Hi guys, in this video we're going to have a closer look at the different data types of tensors in PyTorch. So if not specified when creating the tensor, PyTorch will infer the data type from the values you hand it. The two default data types worth memorizing are int64 for whole numbers and float32 for anything with a decimal point. The int64 data type uses 64 bits of memory to store a whole number. It's an important data type in PyTorch as it is the mandatory data type for indexing, target labels, and token IDs. Float32 is a single precision floating point number, which is a 32-bit computer number format that uses scientific notation in binary to store a data value. It's chosen as a default for neural network weights, activations, and gradients, as it strikes a balance between mathematical precision and computational speed during model training. Unsurprisingly, it uses half the memory of a double precision floating point number, also called float64, which is actually the default precision in NumPy. However, you are not stuck with just the default, as every function used to create tensors can take the d-type keyword argument, allowing you to specify what you want up front. One thing to note is that float to int truncates to 0, chopping off the decimal rather than rounding. Sometimes you already have a tensor and need to change its type after the fact. The to method is the general purpose tool to convert a tensor in some way, including its data type. There also exists shorthands for these operations, where the long method converts to the int64 data type and the float method converts to the float32 data type. One thing to be careful of is that these methods do not modify the original tensor in place, but instead return a new tensor. In addition to float32, there are three other floating point types. Float64 is double precision, float16 is single precision, and bfloat16 uses 16 bits but trades precision for the same range as float32 instead. And so a lot of large models train using this data type. In this for loop, we print out the size of bytes for each type so we can directly see the memory differences. So the question arises, what happens when we mix types in one operation? In this case, PyTorch will automatically promote to the wider type. This means we don't need to convert manually before every arithmetic operation. This type promotion is generous, but it has a limit. In this example, you can see we define a tensor, which PyTorch will infer to have the type int64. The mean value is 2.5, which can't be represented by an integer data type, so PyTorch will throw an exception. Here, PyTorch refuses to guess what you mean rather than silently rounding or truncating for you. To fix this issue, we could use the float method to cast the tensor to a float32 before calling a method like mean. And that's it for this video. Thanks for watching.